Good morning. Today's lesson is all about alkenes and alkynes. Just a reminder, an alkene is a hydrocarbon that contains double carbon bonds, and an alkyne is one that contains carbon-carbon triple bonds. Again, the simplest one, because I need at least two carbons, is going to be ethene. We don't usually call it ethylene, we call it ethene, and ethyne. Those are the common names that you see there written. Okay, so notice when I add the double bond and the triple bond, it is reducing the number of hydrogen that can be attached to that carbon, because remembering every carbon can only have 4 bonds. So there the general formulas then become, because we've reduced the number of hydrogen, so CnH2n for an alkene, meaning if there are 3 carbon, for example, then there would be 6 hydrogen to go with it. And for an alkyne, I've reduced it even more, so if I have 3 carbon for an alkyne, I can only have 6 minus 2, which gives me 4 hydrogen for the alkyne, because those spots are being taken up again by the double and triple bond. Okay, so when I do a condensed structure, we're actually going to draw in the multiple bond. So before, when we were just doing alkanes, we were just reducing it to C's and H's and with no lines except for a branch, but now we're going to leave in the double bond lines and the triple bond lines. So it's just going to make it easier for you to see what the structure looks like in your head. Okay, so how to name it. It's actually not much different than what we have been learning for branch chain alkanes. The only difference is now we have to add a number to indicate where those double bonds are taking place and where those triple bonds are taking place. So again, we're looking for the longest chain. So I'm going to try and find myself the longest chain of carbons. Now it's pretty simple written in a condensed structure. Usually the longest chain is the one written straight across, but if it's a line structure or a full structural formula, then you just kind of want to trace the number of carbons till you can find the longest number that you can trace without lifting your pen, and then that becomes the longest chain. Now, keeping in mind it must contain the double and triple bond. So when you're finding that longest chain, it can't be just a branch, it has to actually contain that multiple bond. Okay, so you can see there blocked out in brown is the longest chain that contains that multiple bond. So once we find the longest chain, we decide, is it a double or a triple bond? So if it's a double bond, instead of ane at the end, the ane, it's now going to be ene. And at the end, if it's a triple bond, is going to be a yne. So we are also going to add the number at the front to indicate where the multiple bond is. Now, really important, the multiple bond must be the lowest number. So it's going to trump any of those substituents that I have now. So remember, we were numbering so that the substituent had the lowest number. Now I need to number so the multiple bond has the lowest possible number for the carbons. Okay, and then the rest of the rules stay the same. So I'm going to number and name the substituents exactly the same as I did in alphabetical order. Alrighty, let's try some. Okay, so taking a look at this first line structure, again, I need to find my longest carbon chain. So doesn't matter which side you start at to find the chain. So 1, 2, 3, 4, 5, 6. So that means hex is the root of my name. It contains a double bond, so the ending is going to be ene. And now I just have to decide where is that double bond. And that double bond, it's hard to see under my yellow line now, that double bond occurs at carbon number 1. So now that tells me I need to label that as 1 to tell me where the double bond is, hexene. Okay, let's try one with a simple branch. So again, finding my longest carbon chain, 1, 2, 3, 4, 5, 6. So again, it's going to be hex. Again, I'm looking at a double bond, so the ending is going to be ene. But now I've got this branch which we know from the last previous lessons that that's called a methyl group. So now I need to start numbering my chain so that the double bond is closest to the end. So obviously that's going to be carbon number 1 way down at the right hand side here. So that makes the branch at 4. So branch parts of the name come first, so it's 4-methyl. Then now I have to add that number for the double bond in there. So that's why that 1 is in there now, because that 1 tells me the location of the double bond. Okay, let's try one with a couple more branches. Okay, so here's the example that I was talking about. So if I wanted to make the longest chain, it looks like I could go 1, 2, 3, 4, 5, 6. But remembering the rule that it has to contain the double bond. So that cannot be my main chain. My main chain has to contain that double bond. So I have to start here. 1, 2, 3, 4, 5. So once I know that's my main chain, again, find that double bond. That double bond is at number 1, so that's going to be pent. And again, the number 1 to indicate the double bond, and it's a double, so it's ENE. And now I'm going to turn to my substituents, my branches in my chain. So I take a look here. I've got 2 carbons, so I know that that's ethyl. And I've got another 2-carbon chain here, so that's also ethyl. So now I know I have to have diethyl because there's 2 identical branches. And hard to see under my writing here, but those occur at 2 and 3. So the name is going to be 2,3-diethyl 1-pentene. Okay, so here we have some alkynes, exact same rules. So we're just going to name them the same, and we'll see that we're just changing the ending to YNE. So when I'm following along here, looking again for my longest chain. So notice when we draw these alkynes that there's no longer a bend in that chain. That's because the orientation of that molecule forces it to be linear. So just remember that you're still counting a carbon here, a carbon here, and a carbon here. So even though it looks straight and we set every bend and every end, but when we add that triple bond, you have to remember the beginning of the triple bond, the end of the triple bond, and then the next sort of bend, I guess, is the carbon. Okay, so when I do this one, obviously I've got 1, 2, 3, 4. Now I could have chosen to go down here for 4. It wouldn't have mattered. It would not change the name at all. But since it's already numbered on my slide, we're going to go this way. So 4, I know that that is bute. So now I've got a triple bond in there, so changes my name to YNE. Again, I indicate the location, so it's 1 because it happens at carbon number 1. And then I take a look at my branches. I've got that methyl group hanging off, and it's at carbon number 3, so it's 3-methyl 1-butene. Okay, and then again the next one. So longest chain is your first task, so find my longest chain. 1, 2, 3, 4, 5. There's that tricky triple bond again. 6 and 7. Doesn't matter if I had gone to 7 straight down again, it wouldn't change it at all. You're still going to have the same name. So 7 is hept. I've got my triple bond here, so I know the ending is YNE. So when I numbered them, if I start numbering on the right side, it actually becomes triple bond at carbon number 4, which is higher than if I started numbering from the left side where I get carbon number 3. So left side it is, I start numbering where the number for the bond is going to be smaller. So it's 1, 2, 3, so that's where I get that 3 for the location of the start of the triple bond. And then I take a look at my branches, and I've got 2 methyl groups, both at 6. So then I'm looking again at a dimethyl. So it's 6,6-dimethyl 3-heptene. Heptine, sorry. 5 is... Okay, now pause the video for a second, see if you can name these, and then just check your answer and start the video again. Okay, so to do the first one, again, longest chain. So 1, 2, 3, 4. So the last part of the name, the root of the name is going to be bute. What kind of a bond do I have? I have a double bond, so that means the ending is going to be ENE. And then I have to take a look at any branches that I have, and there I have a methyl group. So it's at carbon number 2, so that is going to give me 2-methyl-2-butene. Sorry, it's kind of squeezed together. Okay, let's try the next one. Longest chain, 1, 2, 3, 4, 5. So I know that longest chain makes it a pent, and it's a double bond, so that's going to be an ene. And it starts at carbon number 1 if I want to number it so that that bond is the smallest number possible. So that's going to be a 1-pentene. Let's take a look at the substituents. I've got a methyl here and a methyl there, so it's going to be a dimethyl. And they both occur at carbon number 3, so it's going to be 3, 3. So when I put everything together for my name, I've got 3, 3, dimethyl, 1-pentene. Okay, and then the last one. So again, this is the weird straight chain one. So 1, 2, 3, 4. Doesn't matter how, if you go straight or down. So I've got 4. So I know that that's going to be a bute. It's a triple bond, so it's a YNE. And now I'm looking at what number it occurs at. So that's 1, 2, 3, 4. So it's again at number 1. Taking a look at my substituents, again, I've got 2 methyls. So it's a dimethyl, and they occur at carbon number 3. So when I put it all together, I've got 3, 3, dimethyl, 1-butene. Oops, I ran out of room. Okay, and there's your practice. Log on tomorrow at Teams during our class time. I think I set the time at 10 a.m. for us. So from 10 a.m., starting at 10 a.m., I will be taking up these questions. Don't worry about doing D, because we didn't learn rings. So don't worry about D, don't worry about C, because it's got some, or D, because it's got some things that we did not learn. And then one thing I didn't go over, and I probably should have, is di means that there are 2 double bonds, one at 2 and one at 4 in that particular example. Okay, give them a try. I will also add a few from your textbook that might help you do some more practice. Okay, you can try page 186, number 3 and 4. Those are very basic straight chain, alkene and alkynes. So if you want to start with those before you do the branch, that's okay too. Okay, see you tomorrow.